module, that is the last module, and from this last module you will get 2 questions probably, or maybe the 3 question. One best part of this module that you will not get the numerical, you will get only the theory part. Okay, and you will have the fixed question, like from I'll tell you 5 question, and from this 5 questions will definitely come. Okay, so first one is the digital energy meter. It is the important topic. Another one is either from the transformer or from the DC motor. You will get 1 question definite. Maybe from the transformer. If they don't give you the transformer, then they'll give you the DC motor. Another important topic is the AC motor. You will get 1 question from the AC motor. You will get 1 question from the digital energy meter, and then you will get 1 question from the power system. So I told you 4 topics, simply 1, 2, 3, 4, and 5. From these 5 topics, 3 questions will definitely come in your exam, which is of theory only. Maximum of the student leave this module or don't do it properly, but that you don't need to do it proper way. Okay. See, basically the transformer is a device which is used to change, okay, change voltage. Either we can increase voltage or we can decrease voltage. If we'll increase voltage, then that transformer is known as step up transformer. If we decrease voltage, then that transformer is step down transformer. But there is one condition, that is without change in frequency. Okay, that is without change in frequency. Got it? Now the question arises, why do we use transformer, and why there is a need to use transformer? Like suppose you are also using transformer for day-to-day life. You are using a socket like this, right? And you are charging your phone. So do you know the socket provides how much voltage to you? That is how much? Around 220 volt, right? And your phone is having battery, and battery needs how much voltage? That is only 5 volt. So in your in your charger, you are having rectifier device also, and that will studied in B, and you are having transformer, rectifier which converts AC to DC, and then transformer then decreases the. Okay, understood? Now see how the transformer looks like. Rectifier converts AC to DC. Must have studied in B. Sure. So transformer basically decreases the voltage. So how does it looks like? In this we'll have a transformer material. Generally we'll use iron material, or we can use silicon steel material. Silicon steel is more preferable, but it is costly. And we are having windings. This one is the primary side, and this one is the secondary. Okay, in this we are giving applying a voltage, that is V1. Here we are connected with the load, that was motor. Here the current I1 is flowing. All the primary side is denoted by 1 and secondary side is denoted by. Okay, so here I1 is there, here I2 is there, here the number of turns is N1, here the number of turns is N2. Here EMF is induced that is E1. E1 is known as self-induced EMF, and here is 2 is known as mutually induced EMF. Okay, and due to the current, flux is generated, and flux is generated in the material phi. Now the question arises how it works. How it works? Tell me how it works. It works on the basis of Faraday's of electromagnetic induction. Okay, so that is the, we can say, ring principle. So what does he states that E is equal to minus n phi by dt. What is d phi by dt? That is change in flux with respect to time. Got it? Change in flux with respect to time, and where n is the number of turns. If n2 is there, then E2 will be right. If n1 is there, then E1 is right. So now the question arises how there will be the change in flux. Can you tell me how there will be the change in flux? Mainly current depends flux, right? If you are providing the alternating current, means the AC supply, then flux produced due to that also changes. Yes or no? If you are providing AC supply, then flux is produced due to the AC supply. If current is continuously changing at each and every instant of time, then flux is also changing. Yes or no? If flux is changing, then in that case, EMF will induced. Yes or no? Now take it from the contrary side. Take it from the contrary side. If I'll give the DC supply, in DC supply, current will change or not? In DC supply, current is changing. No, no. And if current is not changing, then flux is constant, right? Flux is constant, so it doesn't work. So that's why we always say that transformer never work on AC. Sorry, yeah, DC. Transformer never works on DC. It always works on AC. Correct? Now we'll have two types. Now we are having two types of induction. One, we are having self-induced EMF or self-induction. Another one is mutually induced EMF or mutual induction. Right? Suppose if we are giving supply to the primary winding and automatically EMF is generated to primary only. So that is known as self-induction. And we are giving supply to the primary, but we are getting EMF in the secondary winding, right? That is known as mutual. Got it? Primary supply, primary induction, self. Like you have money and you are buying gift for yourself. You have money and you are buying gift for friend stuff, right? Supply is primary, EMF is also primary. Self induction. Supply is primary and EMF is in secondary. mutual induction. Correct? Now after that we'll have construction is divided into category. One is the core type, another one is the shell type. If we are having transformer like this, as I told you, this is core type, and if you want to make it shell type, this will have a limb in the central limb, and in the central limb only primary winding is connected, and in the central limb only load is connected. In this upper limb, lower limb, okay, in the upper limb supply is connected, and in the lower limb load is connected. Correct? But in this shell type there is a construct like down. Next one is losses. Losses are further divided into category. As you know, we are seeing transformer material and windings, right? This transformer material is of iron material. So we are having iron losses and we are having copper losses. Correct? Copper losses formula is P, that is I square R. Iron losses is further divided into two categories. One is the hysteresis losses and another one is the eddy current loss. Okay, in eddy current losses, how can we reduce eddy current losses? By doing lamination. Lamination means like we are having a material, slide it, cut it into thin pieces and then combine it. That is eddy current losses. And hysteresis losses, how can we reduce? By instead of using iron material, if we'll use silicon steel material, then hysteresis losses will be reduced. Okay. Now the efficiency. If I'm saying I'm giving you 5 questions in your homework and you will be able to do only 4 questions, then how much is your efficiency? 80%. So how would you calculate? You calculate it 4 by 5. 5 questions which I gave you, that is your input. 4 questions you have done, that is your output, right? So what you have done, output divided by input power. Maybe we can write it in terms of transformer, that is output power divided by input power. Correct? So 5 questions I gave you and 4 questions you will be able to do it. Then 1 question is the loss. So what we can say, that input is equal to output plus losses. Yes or no? So output power is how much? V2 I2 cos phi 2, because it's on output means secondary, and power formula is Vi cos phi. Yes or no? And input power is how much? Output plus losses, that is V2 I2 cos phi 2 plus Vi plus Pc. Got it? Hmm? Understood? Eta. This is the symbol of efficiency. Losses is iron losses and copper losses. And suppose if I increase your homework from 5 questions to 100 questions, so will your efficiency be same? Yes or no? Same. If I'll give you, it's not same now. So if I increase your load, your efficiency is changing, right? If I increase the load of transformer, that its efficiency is also change. So basically load depends on current and load is denoted by X. So wherever the X is there means current is there, we need to multiply. PQ is I square R. So we can write it down simply as X. So this is the full and final formula for the efficiency that you need to remember.